Hello all. Yeah, let's move into problem number 34 now. This problem is asking about digit factorials. So here there is an example given 145, and 145 if you take factorial of 1, factorial of 4 and factorial of 5, that becomes 1 plus 24 plus 20, 120, and that becomes 145. That means here the actual number is equal to sum of its factorials of its digits. And so the question is asking how many such numbers are there, and we'll have to find the sum of all numbers whose factorials are equal to sum of their digits. Yeah, let's jump into our coding. Problem number 34. Okay, I'll keep some space here. Okay, first of all, we'll have to create a function that gets the factorial of it. Okay, so I'll just create a function. We have done it in the earlier, but yeah, I'll just do it again. So here, if number equal to 1, we know the factorial of 1 is 1. We'll just return 1. Then else, we'll just return number multiplied by get fact, recursive call, and number minus 1. Okay. Now let's just test this. Factorial of 2 is 2, factorial of 5 is 120, so it's working. Now because we'll have to create the factorial of digits, and you know the maximum digit value in a number can be 9, so it varies from 0 to 9. Okay, so we'll just create a factorial dictionary so that we don't have to do this calculation again and again. Factorial dictionary is equal to an empty dictionary. Now I'll just say fact dictionary of 0 equal to 1, because we know that factorial of 0 is equal to 1 and I don't want to calculate it, I just want to assign it. Then for I in range 1 to 10, because we want to take from 0 to 9. Okay, we'll just say factorial fact dictionary of I equal to get fact of I. Okay, so this is done. Let's check out our factorial dictionary values. So we have got 0 is equal to 1, 1 is equal to 1, 2, and factorial of 9 is equal to this 3, 6, 2, etc. So we got our dictionary ready. Now because in this case we'll get some numbers. Let's say I give you these 3 numbers and I need to find out the digits from this number. Basically from this number I want to figure out a list and to find out a list like 9, 3, 4, 5 and 6. Okay, so yeah, one way to do it is converting into string and looping through the string, because string is nothing but a list. But there is a better way to do that. Let me try to create a function which will take this number and return us the digits. One thing you must see here, for example, I want to find out the digit. How do I get the first digit? Answer is this. I'll just take the modular division of 10. So I got 6. Okay. Now let's say I change the number to this. So I got 9, 3, 4, 5, then again I do modular division by 10, then I'll get next number 5. So that's the idea for this function. So I'll just try to create this function which will take the number and return as the digit. Okay, get digit from number. Okay, it will take the number, and let's say I'll have a list, and that list will contain all the digits for the number. And what I want to do is while number is greater than or equal to 10. Okay, so while number is greater than or equal to 10, that means I have to repeat this process. I can still get the another digit. So my digit, first digit will come as number modular division 10. Then I'm just going to append the number as D. Okay, then I'll change my number is equal to number is equal to number more integer division of 10. So this should be while. Okay, while loop. Now at the end what remains is that is also a digit, so you'll have to append that digit. At the end in this case at the end you'll have number is equal to 9, so just append the number here. Now let's see what happens. So if I just test this, get digit from number, let's say 1 2 3 4 5, 1 2 3 4. Okay, I didn't return this. I should return the list. Here you see I got the number, but I got the number in reverse order. That makes sense because first I'll get the first number, then I'm keep appending in the reverse order. So in order to get the order which we need, we can reverse the list just like that. So now we are getting the number in the correct order. So you can try with any of the number. Okay, let's try this. So you got this. So if you give anything, okay, whatever number you give, you will get the digits in a list form. And once we get this list, then we can look through this list. So that's all we wanted. Another thing we have to notice that what is the maximum number that can form this. So let's say I have a maximum number can be, maximum digit in a number can be 9, and this 9 is 362880. Okay, that means if I have any number where there is 9 in it, let's say 1 2 5 9, this is one of my number, and if I want to sum the factorial, you know, this factorial will become like 362,880, and that means this number cannot be equal to factorial of it. And we'll just do our search, but we'll have to find out what is the up to what level we should search. We should continue our search. I would say because 1 million is a 7-digit number which is greater than this number. So if we search up to 1 million, that should be good enough for our search, and we'll try that. Well, ideally it may not be, maybe we don't have to go until 1 million, but just in case we'll just try to do that. Okay, and okay, before we do that, actually we'll have to create another function. That function will give us the factorial sum of a number. Okay, because that's what we are trying to do. So I'll just get def get factorial sum on factorial sum number. So whatever number I'll pass, this one will find out the digit of this number, get the factorial of it, and sum them up and return us that sum. That's what this function should do. So basically now I need to do the digit list. Okay, so I'll have to get the digit list, which we'll get from the function which we have just created. Get digit from number. I'll just pass the number here, and once we pass it, we got all the digits. Then let's say sum sm is a variable where we'll keep our sum. Then we'll just loop through digit in digit list, and what we'll do is sum plus is equal to factorial of the digits. So we have this factorial dictionary, and we'll just pass the digit and sum it up, and then finally we'll return the sum. Okay, now let's test this function. So you see we have tried with the example given 145. Okay, get digit from number. No, sorry, wrong function. So I'll just try with this get factorial sum. We see get factorial sum of 145 is 145. If I try 146 for example, it is much more than that. So this function is working. So basically when we try our search, we will have to compare. When the number equal to its digit sum, then that's the number we are looking for. So I'll just get a loop for I in range. I'll try up to 1 million. If get factorial sum of I equal to I, then we just print this number. Okay, let's see. Okay, here we got 1 to 145 and 40,584, but remember 1 2 is not the answer. That's what is given because factorial 1 is equal to 1, and these are not sum, so they are not included. So I'll just remove 1 and 2. For do that, I'll just start with 10. Okay, now this is our answer. Now if you just sum these two numbers, the answer is asking for sum of this. Okay, I could add it in a list and do sum, but I'll just do it manually for here. So 40,730. That should be our answer. Let's check it out. Okay, logged out again. And then 733. Okay, let's check the answer. Yeah, our answer is correct. I think that's it for the current problem. Coming up next is problem number 35. If you like my video, please share and subscribe. Thanks again for watching.